So this morning for me, this evening for you, I'm going to talk about JavaScript and accessibility. So we should be able to demystify a few things for you. Hopefully that there's going to be stuff that you haven't heard before, some things that are going to go, hey, this is great. And maybe some things you already know. But let's get started. Obviously, we have not that long, and I'm not going to be able to tell you everything you need to know, but this should give you a bit of an indication. But first, let's start with a story. About 2 years ago, I was going down the street in my wheelchair. I had my service dog pulling me, and it was a really sunny day. So I had wraparound sunglasses, and I get by a little outdoor cafe, and two people were talking to one another. And I heard them say, just loud enough that I could hear, they said, oh my God, isn't it sad? He's deaf, he's blind, and in a wheelchair. So I stopped, turned around, and I said, yeah, but I'm not deaf. The point is, most people don't know that service dogs are more than just guide dogs. You have, like my dog that helps pulling my wheelchair. You have dogs that help deaf folks with hearing. You have epilepsy dog. There's a whole range of service dogs that do things for people. And until you know that, you are kind of stuck within your knowledge. You know, there's this scale of knowledge. There's things you know that you don't know, but there's also things you don't know that you don't know. And this is probably you in your accessibility journey. You may know some things, but not everything. So hopefully we'll answer some of these questions. Who am I to talk about accessibility? I'm Nick. I've been doing accessibility for well over 25 years. The photo on my slide shows me before COVID, when I had a beard and short hair, and things have changed. So thanks COVID for that. I run a podcast called Accessibility Rules, where I talk with people about, strangely enough, web accessibility. And that might be something you are interested in listening to at some point. But let's talk a little bit about accessibility. What is accessibility? And I assume most of you have seen this A11Y and wondered, what is this about? Why aren't we writing accessibility? Why are we using this A11Y everywhere? And it started on Twitter a very long time ago, because way back when we only had 140 characters and we needed to figure out how to refer to things with less character. Accessibility is actually a numeronym, where we take the first letter of the word, so A, and we take the last letter of the word, Y, and then we count the number of letters in between. We have 11 letters, which gives us A11Y. Interestingly enough, it sounds a little bit, looks a little bit like ally, so we often talk about accessibility allies when we're talking about accessibility. But now you know A11Y stands for accessibility, and that's where it comes from. Who's it important for, though? We're talking about accessibility. We're talking primarily people that have hearing impairments. Either they are deaf or they're hard of hearing. We're talking about people with vision impairments. Either they are blind, have some vision, or have low vision. We're talking about people with mobility impairments, whether it's someone who is paralyzed or someone who has tremors and can't actually control a mouse properly. We're talking about people with cognitive impairments. It might be someone who has dyslexia. It might be someone who played sports and got knocked on the head one too many times when they were a teenager. So they have memory issues, focusing issues. So there's a whole range of communities, of groups of people that need accessibility. We're also talking about on every single device. So we're talking about laptops, tablets, desktops, phone. Accessibility is important on all the devices. So when when Jan was talking about, mock-ups on the different size of devices and all that, when you're thinking about accessibility, you have to think about how it's going to work on all your devices as well. We're talking about assistive technologies. What does that mean? Technologies that help people with disabilities. One that we hear about a lot is screen readers. Screen readers are software applications that do a little bit like the name says. It reads what's on the screen. It also does so much more than that. It allows folks that have no vision or little vision to interact with the computer. So you can start out applications, create documents, save documents, interact with the entire computer, and of course get all these interactions through an audio output or even through a braille display output. So instead of sound, you're going to have braille dots on a strip, and that's going to refresh itself as the screen reader is going through the page. One assistive technology that you probably use every day is the keyboard. The keyboard was originally invented to help deaf people communicate faster. Of course, that's changed quite a bit since then, but keyboard is an assistive technology. Talking about speech input, things like Dragon Naturally Speaking, where people have complete control of their computer through voice only. We call that command and control. So you can say, for example, start Firefox, or click read more, or whatever you need to do to control the computer, you can do through these applications. And probably most of you are familiar with the voice assistants, whether it's on iPhone or Android or even on your desktop. We're talking about sip and puff switches. So someone who may have very limited control of their hands may be able to control their computer or their wheelchair, or even with home automation, they can open windows and doors and stuff like that with what is called sip and puff. Basically, it's a strong plastic straw in which someone will either aspirate or puff air in a certain pattern, and then that will create control as to what they want to happen. People can write on the computer using sip and puff, so they have an on-screen keyboard, and depending on how they're using this technology, they can get things done. There's eye tracking, so there's mouse that can be used by following the motion of somebody's head, and how they're blinking their eyes will be clicking or double clicking. So there's a whole range of ways people use computers that most of us are not familiar with, and actually have a significant impact on how we do things. Here's a for instance. We have a form. We decide that the form is needing to be completed in 10 minutes. And if somebody is not doing anything for 90 seconds, we think they're inactive and we're going to log them out. Now imagine that you're actually using an on-screen keyboard, relying on your webcam to look at where your head is going, where your eye is gazing, and how you're blinking to enter one letter at a time. This might conceivably take a lot longer for you to do than somebody who's typing 80 words a minute and is able to zip through the form. So we have to consider all these options, because I guarantee you people are not going to use your web app, your platform, your site in ways necessarily that you've thought about. People are really good at coming up with new ways to use things. People with disabilities are the largest minority group on the internet. We used to say there was about 20% of people with disabilities. A survey from the United States Center for Disease Control showed that there's about 25% of adults with significant impairments. So that's 1 in 4 person, not everyone that has a significant disability has a barrier on the web, but then not everybody that has a barrier on the web necessarily identify as having an impairment. So we have to think about that a little bit. And here's one question I ask people, is which version of browsers are you supporting? Are you still supporting IE11? And if you are, what's the percentage of people using IE11 that come to your website? And I'm willing to bet that is going to be significantly less than maybe the 10 or 15% of people with disabilities coming on. So that's where accessibility is important. But barriers aren't just for people with disabilities. We're talking about things that make sense. If you have gray text on gray background, people with low vision are going to have difficulty seeing it. But if you have gray text on gray background and you're trying to look at this web page on your phone and you're outside in the sun, chances are you're not going to see it. We're talking about if you have a very tiny target for a checkbox, someone using a mouse with tremors may have difficulty tapping the checkbox. But if you're on the bus trying to fill out that form and the bus is shaking, you might have difficulty tapping the checkbox. So there's a whole range of things where accessibility is primarily aimed at people with disabilities, but at the same time, it benefits everyone. But let's talk about JavaScript here. Some of you may have heard, if you've been around long enough, that when you had JavaScript on the website, it didn't work. It was not accessible. It was no good. And we even had a large period of time where the first thing that we would do to test accessibility on a website was turn off JavaScript. And I'm happy to say things have changed. Things have changed quite a bit, because up to 97% of screen readers now support JavaScript. So we, as developer, we have to make sure that the code we push out will actually work for screen readers and everybody else who needs assistive technologies to function on the web. So some of the things we can do to actually increase accessibility thanks to JavaScript, we can provide additional information, we can give warnings, instructions. If you're going to have a timeout where you can use JavaScript to give a warning, you can actually get people to extend the time that they need. So that there's all kinds of really neat little things we can do with JavaScript that will increase it. What we need to keep thinking about is, what do we do? Why are we doing the things we're doing, and how can we improve the experience? Because ultimately, we're talking about improving the user experience, right? So more specifically, some of the things we have to think about is any information we're delivering through visual means, whether it's a progress bar or it's a toaster or it's anything we're providing visually, needs to be interpretable as text. So this progress bar here is showing that we're about, say 60% complete. You need to provide that information as things move, whether it's going from 25 to 50 to 60%. You need to provide that information in a way that is parsable as text. And we're going to talk a little bit more about area later on, but you can use area attributes to do this, or you can actually overlay actual text over the progress bar. So that makes it more easier to understand for sighted people, for people that are sighted but may have cognitive disabilities, or they may be colorblind, or any number of things that actually seeing text is going to be easier than relying on a graphic. On the other hand, graphics are better for a whole bunch of people as well. So we're using a belt and braces approach. One of the things you want to do with JavaScript, you can do is actually manage focus. You don't want to take the experience away from people on your application, on your web, but you want to make sure that if there are things that need to be managed, you can do them. Here I'm thinking specifically about single page applications where you have all the page of a site on one page, but depending on how you interact with the menus, you are delivered to different places. It's not enough to bring visual focus to these places. You also have to bring programmatic focus to these places, because if the only thing you're doing is changing what's appearing on the screen, but you haven't moved the focus to that part of the screen, screen reader users are still going to be stuck where they were before the page moved. I know I'm going fast. I'm giving a whole bunch of information. Hopefully we'll be able to iron out some of the questions after during the comment period. I'm throwing in here keyboard navigation because tied to single page application and key focus management, one of the things you can do as a developer is to test your pages using the keyboard. Now, most developers I know are power keyboard users. When we work in our applications writing code, we kind of forget the mouse and we're just doing everything with the keyboard. And here's a challenge for you. When you use the web, rely on a keyboard. Just use the tab key to go forward, use the shift tab key to go backwards. If you reach an interactive element, whether it's a link, a button, a form input, whatever, you can trigger the action using either the enter key or the space bar. And I give you a bit of a challenge. Go to the websites you spend a lot of time on every day and try to not use your mouse, don't use your trackpad, just use your keyboard to interact with those websites, whether it's a news site, whether it's whichever site you like. Banking is a big one. Obviously, lately we're not traveling so much, but when travel opens up, try to see what the interaction is to use only a keyboard to your airline company. And that's going to give you a good start as to how to test for accessibility, but also an idea of how it feels like. So we're talking about focus management, right? I said we can control where the focus go. I said we can use the keyboard to navigate. And we're talking about what elements can receive focus natively, that is. So obviously we have links, we have buttons, we have form elements, we have iframes. Those are the primary elements we're going to encounter on a site that natively receive focus. There's a long list of them on that link on the slide. But that's important to know, because what we're doing a lot with JavaScript, whether it's, we have our own versions, or we're playing with React or Angular or Vue, or you name the popular framework, chances are that everything is going to be loaded as a div or as a span or as a non-semantically meaningful element. And then we do a whole bunch of magic to kind of replicate what is a native experience. So we want to avoid that in general, rely on native HTML where we can. However, sometimes we have no choice. Sometimes we have to be able to put focus on things that don't naturally receive focus. And there's two ways to do that. First, we would add the tab index attribute. And we can put a value of 0, which means that something that is not focusable normally natively would be able to receive keyboard focus. Or we use a -1 value, which means that we can apply programmatic focus to an element. Here's an example of how we would use that. Is if we have a skip to content link, the first link on a page allows users to bypass your mega menu. We need to allow programmatic focus to the element that where it's going to. So if we're skipping to main content and it's going straight to a heading, that normally would not receive focus. So we would put tab index -1 on the heading, and then all the assistive technologies that are playing with these information will be able to move the focus and get the screen reader user at the same place that sighted user are going. That said, tab index, be careful. Don't use positive tab index. Never use positive tab index. And I will say this again just to make sure that it's clear enough. Don't use positive tab index. The reason you don't want to use positive tab index is that you're messing with the natural sequence of navigation. And it's so easy to get to a point where you forget one, or you make a change on the page 5 years later and suddenly things are changing. I spent about an hour doing an audit a couple of weeks ago where I was looking at a button and I could not tab to this button. I was just tab, 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 and it kept skipping. And when I looked at the code, I realized that they had put tab index 1 on the button. But because they had not applied any other tab index on the page, that means that I had to tab through every single interactive element on the page before reaching the element that had a tab index 1. So probably someone at some point wanted to make this more accessible, and what they did, in fact, was make it less accessible. One of the things that we have a lot of problems with is modal windows. We use them often, but they have a lot of problems typically. So they don't typically appear in the regular tab sequence. So we want to make sure that when they are open, when they are triggered, we keep the keyboard on the modal until the modal is closed. It is nothing more frustrating for either a screen reader user or a sighted keyboard only user to tab onto the modal, and then they keep tabbing, and suddenly the modal is still present, but the cursor is behind the modal, and then trying to close that is really tricky. We want to set focus on the modal dialog heading, so a screen reader user gets the information that sighted users get immediately, and you want to be able to close it with the escape button or with the close button. So you want to make sure you have an event listener for the escape key that will close the button. I do have a code pen that we don't have time to look at right now, but if you look at bit.ly/accessible-modal, you can have a play with that. Event handlers. We're talking about listening for the escape key. So we have access to a whole bunch of event handlers, whether it's device dependent like on click or on enter, or device independent that listen for the mouse and the keyboard and whatever other ways to provide input. And typically we want to rely on device independent because we don't know how people are going to use our site. So don't try to use only device dependent handlers. Try to use device independent. However, sometimes there are no event handlers that will react to both. So you have to duplicate a bit of your work. You have to pair your event listeners. So whether it's mouse down and key down, you can combine these to write a function that will trigger your event. In general, you want to focus on the purpose of what you want to do, not on the mechanics. So it might be that you're having to change a little bit about how you think about the interaction on the web. You want to think about what the user needs to accomplish more than how you're going to allow them to accomplish that. So you really do want to provide a wide range of ways to get to the same point. This works well with navigation. So you want a sitemap, you want a main navigation, you want a search that gives your user different ways to find information on the site. In the same way, you don't want to make sure that somebody will need to click a particular element to make it work. You want to allow them to be able to use the keyboard, or to be able to say, hey, Dragon, uh, activate the search button, or whichever the commands are. You may need to have some flexibility on how you want to get things accomplished. Um, you can, with JavaScript, with ARIA, you can modify default behavior of things. And in general, you want to avoid that. Um, we'll talk a little bit more about ARIA in a moment, but some of the things you want to be aware of is if you have a heading and you give it a role of image, suddenly you've changed the default behavior of a native HTML element. And while you can do that, maybe you should not necessarily do that, because there's so many things you have to consider when you're replicating that default behavior. Um, Dynamic content. We have a lot of times where we have expand and collapse sections. So we activate a little plus icon and suddenly we have a whole bunch of content. Or we have uh, dynamic page refreshes, or we have tabbed interfaces on our page. Some of the things you have to consider is um, can you trigger that with the keyboard only? And strangely enough, you have the tools at your disposal. You're able to use your keyboard and test it. You're able to see if what you've built is actually going to work with the keyboard. Um, you have to check that the content within the keyboard, the section that's been exposed, is accessible itself. And typically, you also want to notify screen reader users that something changed on the screen. And this is where we're going to start talking about ARIA, ARIA. Um, I don't know if you've really been aware of why ARIA. You probably have. You're probably using it without really understanding where it comes from, what it's about, and that's what we're going to talk here about. Um, ARIA is an acronym that stands for the Accessible Rich Internet Application. This was developed a while back when HTML did not have a whole bunch of built-in accessibility features that we have now. Obviously, HTML always was accessible, always had a lot of accessibility built in, but there were things that we couldn't quite do until HTML5. So this specification was developed and allowed to modify behavior, default behavior in elements to provide more accessibility. The first rule of ARIA. Obviously here it's a little bit difficult to do on Zoom, but take a moment and try to think about what do you think the first rule of ARIA is, and maybe maybe in the chat I see Tim is saying don't use ARIA. Anybody else maybe has a suggestion at what the first rule of ARIA might be? Any other suggestion than that? Yeah. Well, Tim is correct. The first rule of ARIA is don't use ARIA unless it's necessary, of course, because there are valid reasons to use ARIA. There was a report done a couple of years ago called the Million Web Page Accessibility Report. And that showed that The pages that had area on them were on average 61% less accessible than the pages that did not have area. So while we can use area to improve accessibility, in general, the way we use it is making things worse. It's also symptomatic of the fact that the more area we use, the less semantic HTML we use, and that's really making building problems for a lot of people. Um, for example, the semantics versus area. A button is a button, a div is a div. You can make a div behave like a button, but you have to do a lot of heavy lifting. For example, if you want a div to behave like a button, you want to add a role button, you want to add a tab index equals 0, you want to uh, add your event handlers, you want to do a whole bunch of things to make it behave like a button. And chances are you're going to miss one or two, and then your button that you think is working is not going to work for a lot of people. The other aspect to that is when you're using uh, non-semantic native elements, you are actually increasing the weight of your scripts. You have to use so much more. On average, I think it's about 75% more code to make non-native elements behave like native elements. So it's building a lot of code and reducing the performance of your site. Anyway, some of the roles that you can apply, for example, if you have a form, you could put roles search. If you have a little tooltip, a little icon with the eye for more information, you can apply a role of tooltip that's going to impart some information to the assistive technologies. You can add the role alert to an input. So if something needs to be passed on to the user immediately, you can say, hey, this is a role alert. And if something changed here, that's going to inform the assistive technologies immediately. We were talking about a slider earlier. We can use an input, say it's an image, and then we can give it a role of slider. So suddenly the assistive technologies coming to that element will get additional information about what this element is intended for. Uh, the other aspect of area is that we have a whole bunch of properties and states that we can define. Uh, for example, if you have a required input, you could use the area required attribute and say true. This came before HTML5 and the required attribute in HTML5. I personally still prefer to use area required because if you use the HTML5 attribute as a screen reader coming to that, it will immediately start browser validation and could be quite confusing. Uh, Other things you can use area described by, and then you would give the idea of an error message. So if you have an input, there's an error message, you want to associate the error message to the input. So a screen reader coming to that input is able to get the error message, not someone, not just have it visible for sighted people. You have, for example, area expanded could be used for expanded collapsed things. So you put area expanded on the button, and depending on the state of the content, whether it's exposed or not, you would change the value of that. If you want to hide something from assistive technologies, you can use the area hidden attribute, and that would make it still visible for sighted users, but the assistive technologies would ignore it altogether. And we have area live. I gave an example on this slide of area live assertive, and I'm going to talk about that in a moment. I said earlier, dynamic content, we needed to be able to notify screen reader users when something changes. And that's how where we use live regions. And there's three values for live regions. Either we have area live is off. If that's the case, then basically there's no live region there. 99.9% of the time, we don't actually need to use area live is off, but it's there in our toolbox if we want to use it. The other want is area live assertive. This actually, when the specs were being written, we were talking about calling it rude instead of assertive, because it is actually very rude. What this does is, if something changes on the page and it's got the assertive value of the area live attribute put on, the screen reader is going to stop everything it's doing and start saying whatever is in the live region. One of the ways we see it often is for form online validation, where until the email address is finished to be written, there's this validation that says, this email is not correct, and this email is not correct. And with each character you type, it's basically giving you that email address that this email format is not correct. Now, as a sighted user, we see this message appear and we cannot block it out as we type. It's just the same thing. Maybe it flashes a few times, but that's not a problem. But if we're using area live assertive, the screen reader is going to be doing a whole bunch of stuff. The first thing is, with each letter the user is typing, the screen reader is going to announce what letter is being typed, which is fine. That's what we want. We want to know that if we type an A, we didn't type an S. But if you have area live assertive, every time a letter is typed, the screen reader is going to stop reading the letters, and it's going to say there's a problem with this email address. And then you type the next letter and it's going to be there's a problem with this email address. So we really want to avoid using the assertive value of area live unless there's something that is really dire and urgent. They clicked a button, which means that the entire web is going to explode in 2 seconds. They need to know about this immediately. The value we want to use in live regions most of the time is polite. And basically that says, okay, hey, screen reader, listen to this. Something changed in this div, but finish what you're doing before you start announcing it. And that really gives better information, better access to the information without being interrupted all the time with what they're doing. So this is it. Obviously, we're going to have questions, but there's a lot I talked about, and we had very limited time. So hopefully that was useful for you.